In this segment, we're going to close out the course by returning to some of the earlier discussions we've had about ethical issues in NLP. And so I want to give a kind of broad overview here of the different sorts of issues that we might want to think about so that we can kind of categorize these things and think about, basically have a system for breaking down what the possible pitfalls are with each of the techniques we might use. So we could think about these in two ways. So first we could think about, from a kind of system point of view, for each of the different applications we've seen, what are some of the kind of problems that it might have? And then there's also sort of a more general class of problems that emerge from using machine learning and deep learning. What I want to do is I want to articulate 4 different types of risk, types of ethical risk, and discuss some instances of each of these so that you understand kind of what to look for here, what some of the problems that show up can be from applying these systems, and then, in some cases, maybe what some hints towards solutions might be. Most of these do not have easy answers. Okay, so one type of risk we're going to talk about is what I'll call dangers of automation. Basically, when we're using systems for machine learning and deep learning, we're both automating things that previously weren't so easy to automate, and we're also doing it with techniques that we don't necessarily understand, or we can't understand what they're doing all the time. And so that can have some risks in terms of, the system kind of runs away with some sort of behavior that we actually don't want. It may not even be obvious that it's doing that. Another risk is what's called exclusion, which is that we have a set of users who are underprivileged. Maybe they speak a language that hasn't had Google invest a whole bunch of money into building tools that work well for it. And so now everyone else can use systems like Google Translate, but maybe their language isn't supported very well by Google Translate. And so, everyone else is accessing all this information out there and they aren't able to. Bias amplification. This is a little bit of a more specific one it's almost a kind of subclass of dangers of automation, but is kind of its own, its own area that gets a lot of study. When we apply a system to some kind of setting and there might be a place for real world bias to creep in, there's a concern that that model is making mistakes by exacerbating real world bias. Now, there's lots of times when machine learning models take, bias in their training sets and reproduce it, but we care about this particularly when it might represent some form of discrimination. And then finally, there's just kind of pure unethical use of a lot of these tools. And so we'll talk about what that looks like at the end. Okay, I want to actually start with this bias amplification case. So this is some work from Zhao et al. From NLP 2017, where they looked at a task called visual semantic role labeling. And so what they have here is they have images of people doing stuff, and then they have basically sort of slots to fill with values. And so in this case, you have a cooking activity, that's the predicate in the SRL terminology. And then the agent here gets determined to be a woman, which is incorrect. It's a man cooking. And the problem is that 67% of the training images involving cooking are women. So there is bias in the data, and that bias is in the test data as well. So we would expect the model to, if it were perfect, also predict 67% of the test images, as involving women, because that's truly what it was. But in fact, what happens is that the model makes mistakes, and those mistakes are systematic. It tends to overpredict women cooking at test time. And so this is what we call bias amplification. It's not just kind of randomly making errors in the new data, but it's in fact making these errors in a way that is exacerbating this bias that was seen in the training set. And so the solutions for this basically look like trying to sort of constrain these fractions and regularize the model to not in aggregate predict more women than men. And so there's various forms of kind of tweaks to training and stuff that have been used to do this. And what they showed was basically, a result which is only medium convincing, that each of these points is a particular role that has some gender ratio in training and some gender ratio at test time. And so what we really care about are cases like, the things kind of above the line here, where maybe the ratio was 80% in the training set, but now it ends up being 100% in the test set. And they sort of apply this this kind of regularization, and they manage to get more things that are kind of close to this line of matching things between training and test. So this is one way of thinking about trying to reduce the bias in these models from an actual predictive point of view. Sometimes it's not so easy to analyze. So for example, if we're doing machine translation and we have the sentence in English, "This dancer is very charming," when we translate this into French, we actually need to impute a gender for the dancer. And so in this case, the translation system says, "Cette danseuse est très charmante." And the assumption here that the system makes is that the dancer is female. And why does it make that assumption? So Alvarez, Mellis, and Yakula did some kind of analysis of this and showed that, okay, in this case, actually, we could say that the danseuse is being attributed to the word charming. And so maybe the assumption that the dancer is female is because of the use of the adjective charming here. And so this machine translation system is maybe reproducing some real world biases in how language gets used. And maybe that's right, but maybe that's wrong. I mean, maybe that's not the kind of thing that we want to propagate into our systems. And so when we think about this kind of bias, we have a question of, okay, what is our objective here? Is it just to get the kind of highest accuracy, in which case maybe reproducing the bias in some cases is what we want, or is it to make a system that's maximally fair? There's not always an easy answer to this question, and it's not always easy to define fairness. And so, but we need to have tools for understanding these different effects and ways of kind of breaking this down, isolating these factors in a vocabulary for talking about how to address them. Okay, I'm going to talk about exclusion now, which was another one of our big kind of top 4 points. And the bottom line here is that a lot of this annotated data is in English. And how does this work out for things like people who primarily use dialects that aren't standard written English, people who speak languages where there might not be these same kind of annotated resources, and situations like code switching. What if what if you're bilingual and you often speak kind of using words from different languages in the same sentence? Now, for each of these settings, we saw some techniques for doing things like cross-lingual models that can handle some of this stuff. But it's still the case that without fine-tuning data in each of these settings, no matter how good your pre-training is and how good your cross-lingual modeling is, there's always going to be some kind of gap here. So there's a lot of thinking about how to broaden this stuff. Projects like Universal Dependencies is trying to annotate tree banks for a lot of languages. Masakane NLP is a collective of African researchers who are trying to build better machine translation systems for African languages, which have been historically excluded by a lot of these tools. Okay. Dangers of automation. So this is a kind of broader category that includes a lot of these things, and I think this headline sort of summarizes what goes wrong here well. Facebook apologizes after wrong translation sees Palestinian man arrested for posting "Good morning." Facebook translated his post as "attack them and hurt them." Okay, that's kind of crazy, right? Someone actually looked at the automatic translation on Facebook and someone got arrested as a result. But this is the kind of thing that happens when you deploy these systems in the real world and you can't make firm guarantees that they're correct. So even though these translation systems are typically helping spread information and let people read stuff that they otherwise wouldn't be able to read, there are definitely risks here as well. Translations, when people use them to produce text in other languages, they also run the risk of doing things like producing offensive terms. So these are potential translations for gay listed in, in Google Translate. And, on the one hand, it's useful to know that these are, possible different terms. But then on the other hand, if someone were, writing something and using Google Translate as a resource, they probably would want to know the sort of cultural trappings of all of these terms and, how offensive certain people might find them based on, before they go writing this stuff, right? Another, this kind of ties in with the sort of bias ideas as well. When you start automating things, you start having to think about these other factors again, other than just accuracy. You have to think about the kind of externalities of the system. So Amazon had this screening tool for resumes that they scrapped after they found that basically being in a women's organization or going to a women's college were negative weight features. And this scenario is tricky because they trained this based on who actually passed their interviews. And maybe it was correct in that, bias in the interview process was also going to lead to women getting rejected further down the pipeline. We don't really know without doing a deeper study here. So it's hard to define this in terms of just accuracy on some kind of test data. We need more rigorous notions of okay, how should this behave? Maybe we need to sort of produce a contrast set of here's the resume, here's a resume with the same skills as the resume the man has, but now it's a woman and she went to a women's college, and the system should do the same thing on both of these. So it's it requires thinking about the risks of how you've automated things and what the different mistakes the system can make in order to understand in order to understand what we should do. All right, and finally another example from Degeneration is the idea of what's called toxic degeneration. There's a lot of interest in these systems like GPT-2, GPT-3, but if you put in a relatively innocuous context, I'm sick of all the politically correct blank, it will start to make highly political statements, and you probably wouldn't want this to be generating text, without being able to vet this stuff to make sure it's not saying offensive things. And again, the solutions aren't easy. We're training a statistical model on the web. When you see, if the web is what you're going to take as data, and you condition on words like SJW or black, and you ask the system statistically what should come next, there's a lot of bad stuff that has a pretty good chance of getting surfaced. But this is the kind of difference between building a system, between kind of collecting statistics from the internet and actually building a system. When we build a system, we want it to do good in the world. We don't want it to kind of say toxic things or reject women from jobs and things like that. And we need a process for kind of moving away from what's in the training data and towards the actual kind of thing we want to have. All right, and the last kind of point I'll touch on here is that the ideas of unethical use. So, a lot of NLP potentially and information extraction and other techniques in deep learning like computer vision have applications in things like surveillance. Like, can we scrape Twitter and find all the people who are talking about this company in a negative way or something like that? And sometimes this is innocuous. The company just wants to know who likes and doesn't like its products, but this can easily turn spooky. And another idea is kind of generating fake news or fake comments. So these are comments taken from the FCC's website when there was a proposed change in net neutrality rules, and it was found that many of the comments that were in support of the rule change were algorithmically generated. So it turned out that these basically came from templates, but what if they were undetectable? It was kind of a way for kind of bad actors to say, actually, there is a lot of public support for these rule changes, even when that was not the case. Most people were, the large majority of people were coming out against them. Another case which is a little bit more nuanced, this is not from NLP per se, but from folks at Stanford who they built a classifier to classify someone as gay or straight based on their face. Okay, so they argued that they were trying to test a scientific hypothesis that that sexual orientation has a genetic component that gets reflected in your appearance. And so their view was, well, okay, if we can do this, that is some kind of scientific evidence in favor of this, and maybe this is telling us something useful. Okay, the problem was that it turned out that the science here was not good. There was a blog post by Agariarchus, Todorov, and Mitchell who showed that largely this was detecting features that you do have control over, like whether you're wearing glasses or not. And so it actually, the kind of evidence, quote unquote, that it supported this hypothesis of physiognomy that like, you know, this stuff is kind of reflected in your face, was not even really there. It wasn't good science. And then the other question to think about is like, okay, well, maybe this would have some scientific benefit, but it's also potentially dangerous, right? Like there might be authoritarian regimes that want to make being gay illegal, and so they might catch wind of the fact that, oh, there's this classifier, you know, we'll just get people to look in the camera at the airport, right? If they want to enter the country, and we'll classify them, and then, you know, if they're gay, we'll throw them in jail. And so the question is, does building the tool here, do the benefits outweigh the risks in this case? And given that the benefits were shown to be marginal to none, I think the answer to this is no. And then there's this has been taken to extremes. There was a startup called Faceception, whose idea was to classify you as, you know, classes including high IQ, academic researcher, professional poker player, or terrorist based on your face. And so this obviously was rife with possibilities for racism. It's like not founded in any like real scientific thing. Maybe in some cases there'd be some weird cue that the system could pick up on that would convince them that it was doing this. But like, this is the kind of thing that just shouldn't even be built from the perspective of ethics. So we've mapped out here a collection of different ethical issues, and one question is how do we kind of move forward? So there are a few different frameworks for thinking about this stuff and assessing when we're building tools, whether or not those are tools we should be building and how we should handle some of these issues. So Hal Domé has a proposed code of ethics for NLP and machine learning, which has a few points about, these are kind of high level things, but at least give a framework for discussing some of these issues. Another framework is what's called value sensitive design, thinking about when we're building a system, whose values matter and how technology impacts that population and those values. And one kind of example of this is, if you're building a system for something like online education, maybe you shouldn't just talk to teachers, but you should talk to students as well and understand their values and how things like invasive proctoring software might negatively impact them. So this gives us a kind of language for thinking about these kinds of ethical issues. And what I hope you'll take away from this is an idea that, there are several different types of things that we need to think about when building these kind of systems for NLP and machine learning more broadly. We've seen some examples here, and so hopefully you can remember those and kind of carry them forward and apply them to situations that you look at in the future. And just be aware that there are these frameworks out here for analyzing and thinking about these issues, and this is something that we should be doing when we whenever we try to solve problems with the kind of NLP technology that we've seen in this class. So this technology has incredible potential to do good, but we need to make sure that as we develop these techniques, as we build this stuff, we're actually making the world a better place as a result. That's the end of this segment.